Hello everyone, I'm Bingyang Wu from Peking University. I'm glad to share our work, XRON, a hybrid elastic cloud overlay network for video conferencing at planetary scale. This is the joint work of Peking University and Alibaba Cloud. In recent years, video conferencing has become increasingly popular and important in our society. As one of the largest video conferencing services in the world, DingTalk serves over 500 million users for their long-distance communication and collaboration. To provide planetary scale video conferencing services, DingTalk deploys software in multiple cloud regions of the public cloud without building hardware infrastructure in each nation. For cross-region video conferences, multiple clusters transmit video streams with each other. In this case, the quality and cost of the network are two key considerations for planetary scale video conferencing services. However, simply using resources provided by the cloud platform cannot meet the requirements of video conferencing. The cloud platform provides heterogeneous network resources, including internet links and premier links, but they are imperfect. Internet links are cheap, but they are unstable due to their best effort nature. As shown in the figure, the loss rate of internet links can be as high as 30% and is much higher than that of premier links. As a latency-sensitive service, a high loss rate greatly impacts the fluency of video conferencing. Premier links can provide high performance for video conferencing but are too expensive to afford. The unit egress fees of premier links are significantly higher than those of internet links. Therefore, it is challenging for video conferencing to use these heterogeneous network resources. At the same time, unlike traditional on-premise deployment, cloud-native deployment has to deal with a unique elasticity problem. The video conferencing demand is highly dynamic each day. As shown in the figure, video conferencing demand surges multiple times in a day and may increase up to 3.4 times in even 5 minutes. In this case, satisfying the stringent latency requirement of video conferencing is challenging. To solve these challenges, we propose XRON, a hybrid elastic cloud overlay network for video conferencing at planetary scale. XRON differs from prior overlays with two distinct features. First, XRON hybrid leverages both internet and premier links simultaneously to achieve high quality and low cost. Second, XRON exploits elastic cloud resources to adaptively scale capacity based on real-time demand. An intuitive idea for using heterogeneous network resources is to use direct interconnection between multiple regions with fixed network tier selection. Based on experience, if an internet link between two regions is often unstable, the operator can direct video streams to transmitted by the corresponding premier links. However, because many internet links are unstable at some unpredictable times, substituting them by premier links still incurs high operation costs. In contrast, XRON applies overlay forwarding for video conferencing. When network degradation occurs, XRON dynamically combines two cheap internet links to route around the unstable internet link while maintaining low cost. This technique is adopted by many existing overlay solutions, but it increases the RTT of video conferencing. The key insight is that network degradation often only affects one direction of an overlay link in production. The figure shows an example that only one direction of an overlay link has a high loss rate, while another direction is good enough for video conferencing. If simply using the round-trip performance of links to compute the forwarding plan. The solution space is limited, and the forwarding decisions are suboptimal. Consequently, with the help of the scalable group-based active probing mechanism, XRON collects each direction of overlay links separately and uses asymmetry forwarding to further reduce the latency and cost of video conferencing. It works for long-term network degradation. However, when frequent short-term network degradation occurs, each time media servers has to interact with a globally centralized controller to update forwarding tables. It is still slow for latency-sensitive video conferencing. To handle short-term network degradations, we propose the fast distributed reaction mechanism. The key insight is that the data plane can use premier links without immediate coordination of the control plane. The XRON controller proactively pre-computes and deploys fast reaction planes in the data plane. When network degradation occurs, the data plane of XRON can temporarily using the backup path to circumvent unstable links without involving the control plane. By temporarily leveraging premier links, changing the path does not break the network and performance degradations. As shown in the figure, frequent video conferencing spikes ask for a quick auto-scaling mechanism. Otherwise, it may significantly hurt the performance of video conferencing. However, the traditional reactive container auto-scaling mechanism provided by the cloud platform cannot meet fast requirement changes. When the traffic demand surges, the capacity cannot increase until a series of slow initialization and checking procedures are done. As a result, users of video conferencing may experience video source and bad audio fluency. Our key insight is that the traffic demand conforms to users' regular daily routine. The video conferencing demand surges when the work time starts and falls back when the work time ends in the morning, afternoon, and night. The figure shows an example. Because video conferencing is mainly used for daily or weekly meetings in the company and scheduled online classes in the school, we can accurately predict the video conferencing demand in the near future. Based on this insight, we propose a proactive auto-scaling mechanism. It uses video conferencing statistics to predict traffic demand and proactively auto-scales containers and updates overlay routine. Therefore, XRON can overlap demand changes with capacity control to provide high-performance video conferencing without over-provision. XRON has been deployed in production. Large-scale production deployment shows that, compared to the internet-only version, XRON reduces the video store ratio and bad audio fluency of cross-region video conferencing by 77% and 65.2% respectively. To conclude, XRON is a hybrid elastic cloud overlay network that combines cheap unstable internet links and expensive stable premier links and exploits elastic cloud resources to improve QoE and reduces cost for planetary scale video conferencing. XRON has been deployed in 11 cloud regions across 4 continents to support DingTalk since August 2002. Thanks for listening.